Good afternoon or good morning, depending on where you're calling in from. Thank you for joining us today for this webinar entitled Ignite Your Data Center with a Private Cloud in a Box. And this webinar is brought to you by Cloudistics. We're happy to have Cloudistics here with us today. And we have the very fine Mr. Todd Frederick here, the Chief Revenue Officer and co-founder of Cloudistics, to join us. Todd, thank you for being here today.
Absolute pleasure. Thank you for having us.
And my name is Scott Lowe. I'm vExpert, and I'm also a partner and co-founder in Actual Tech Media. And before we get into the meat of today's event, we're going to make sure we have a couple housekeeping items taken care of. First of all, should you have a question, there is a questions control panel in the GoToWebinar control panel that you should use to ask any question you might have about today's topic. And we're going to be taking questions at the very end of the event. So if you have that burning question about cloud or about hyperconverged infrastructure or about life in general, please feel free to use the questions control panel in the GoToWebinar control panel. And with that said, we'll get started with today's content. Our agenda today is going to be talking about some modern enterprise IT challenges. And then we're going to talk about the cloud and some unexpected results in an ideal world, what things would look like with regard to cloud. And then Cloudistics will take over and talk about the Ignite on-premises private cloud in a box. Then we'll do some wrap-up with Q&A, and we'll give away 3 $100 Amazon gift cards to 3 lucky people. So, what are some of the challenges facing enterprise IT today? Well, first of all, we have continually changing technology opportunities. It seems like this is the state of things more and more. I mean, it doesn't seem like things are slowing down as far as change goes. It doesn't seem like that long ago when you could maybe go a couple weeks without some new vendor coming into space and trying to upend it all. Today, almost every day, we're seeing really cool new things happen, and we have to find ways to try to leverage those opportunities to meet increasing demands of the business. On that note, we see businesses that are continuing to demand faster speed, more agility, and more flexibility in IT operations and at a lower cost. Now, these are seemingly mutually exclusive goals, but fortunately, there are solutions on the market today that can help IT better meet the needs of the business in a more cost-effective way than we have in the past. We also have to face the real problem, or sometimes opportunity, around what we call shadow IT. Those are those services that are not officially sanctioned by IT that can sometimes create problems for the department. We'll talk about that in more depth in just a few minutes. We also have the rise of things like DevOps and new ways that we think about operating the environment. And we have to think about these things because they allow us to add that agility and flexibility to our infrastructure environment and to the business in ways that we didn't anticipate just a few years ago. And this is also a challenge, but also an opportunity, but it's also easily accessible cloud services. And we're going to talk more about that shortly as well. Now, let's talk about shadow IT. So when we think about what the business needs, you know, in a perfect world, the business would come to IT and say, IT, we need this, and here's a bunch of money to do it. Well, unfortunately, that doesn't always happen. And what we end up with is an IT organization that's really under-resourced and understaffed a lot of the time. And we're focused often on putting out fires rather than really focusing on helping the business move forward. We have a hard time with the strategic side of things. And Todd, I'm sure you've seen this when you've talked to some of your potential customers. They're just underwater all the time. Is that an accurate statement?
Absolutely. You know, it's firefighting, you know, from one fire to another and then back to the fire that they thought they put out last week.
Yeah, and a lot of that comes because of the way we've had to build our environments. But the challenge is that the end result is that the business has needs that are not being met by IT. And it's not necessarily IT's fault, but unfortunately it's something that we have to fix. And the other thing that we have in this case here is we have end users that are far more tech savvy than they used to be, and that they're often given credit for. But there's a flip side to that. They may know how to use the technology, but they don't know how to integrate it, and they don't know how to secure it. In fact, Gartner says that by 2020, a third of successful attacks on enterprises will be in their shadow IT resources because they're not always properly secured. They're integrated in less than secure ways with other systems, and it becomes an opportunity for miscreants around the world to have their way with your infrastructure and steal your data. And so we want to find ways that we can avoid this situation and solve the problem. And here's the other thing that has happened in recent years. We've had, because of all this stuff, because of IT being so, under-resourced, understaffed, and really challenged to provide the level of service that the business needs, and because we've seen so much shadow IT crop up, we have the C-suite coming in and saying, we need to push everything to the cloud, Amazon. And what they mean by that is to Amazon or Microsoft Azure. In their mind, that's what they think. They've heard about all of the good things that the cloud can provide, not necessarily understanding all the downsides, which we'll talk about shortly, but they say we need to do this because this will help our business be more agile and we'll save money. Well, here's the problem. When we think about the cloud, there are lots of good things that can come from it, the public cloud. We get some ways that we can move to an operational expenditure-based model rather than a capital expenditure-based model. We can deploy things much more quickly because basically we can click a button. We can get IT with a credit card, so we don't have to buy a lot of stuff up front. But it comes with some trade-offs. We have seen organizations that get surprises in the mail every month when their bills come because somebody made a mistake or because they've gone past what we call a financial break-even point. There is a point at which building your own infrastructure and managing it is less expensive than managing it in the cloud. And we've seen organization after organization start to say, hey, maybe we shouldn't be putting everything in the public cloud. Maybe there's a balance we should be achieving, or maybe we should actually bring some of it back on site. And we see even companies like NASDAQ have done this in the last couple of years. They've looked at their cloud bills and said, this isn't making sense anymore. We have to find a way to do this locally because it's going to save us money. And when you go all in on a single public cloud, you don't really have an ability to balance workloads where it makes sense. There's some workloads that simply have to run local. And if you decide to go all in a public cloud, you still can't ignore what you're doing locally because you have to have some place to run those local workloads. Then we have the potential for security challenges, and this is not just a breach. We also have issues today internationally around things like data sovereignty. So where is data going to live? In what jurisdiction is it going to live? And based on that, what kinds of unexpected compliance burdens am I going to have to face, or risks will I face because of the fact that my data could be housed in some other country and subject to its laws and restrictions? And that's a real challenge that people see with regard to public cloud. And when we start to think about this in terms of shadow IT, with people just buying their own public services, we end up with inconsistent deployments around the organization. And one of the nice things about centralizing and controlling things is we can get some economies of scale. When we take that out of the equation, our costs go up, our complexity goes up, and our ability to react to changing business needs goes down. That lack of IT control can be a challenge for a lot of organizations. Now, for some people, that seems to be a really great thing. Let's not have IT control things. But there's a balance that has to be met. I'm a believer in that IT has to control things, but I'm also a believer in that there has to be governance in place so that IT is not simply calling the shots all the time. We don't want an organizational structure of command and control. We want something that's centralized, but with shared decision-making around how things are going to work. Then these shared resources are critical to the business. IT is a shared resource. We have to treat it as such and embrace shadow IT and find a way to solve those problems those end users are having so that we can move forward with the business of the business. We then start to see things like potential performance problems in the cloud. We don't control the hardware. We're sharing it with other people, and we can't fix things on our own. And that also results in potential compliance issues. Again, it goes back to data sovereignty. If the data is not secured properly, we could get in trouble, and things like that. And when things are out of your control, even if availability is not worse than it is with your local data center environment, it feels worse because you can't do anything about it. And there's no worse feeling than sitting in a room and saying, this is all going down and there's nothing I can do about it. Todd, I'm sure you've faced that in the past where fires are burning all around you and your hands are sort of tied.
Absolutely. It's kind of frustrating.
Yeah, no fun at all. Now, here's what I believe. Companies are not looking for, quote unquote, the cloud. I truly believe that. Even if they say we have to move everything to Amazon, they are not looking for the cloud. I believe cloud is a journey, not a destination. So what's really happening here is those companies are looking for what cloud can provide. They're not necessarily looking for what it is or where it's going to live. And so that's one of the things we have to keep in mind as we move forward, is that we have to find ways in IT where we can bring cloud-like characteristics to any environment, whether that's local or whether that's actually in the public cloud. But I think there's a lot of organizations that want to keep things local, but they want cloud-like characteristics. They want to de-emphasize their huge CapEx spend that they have in the data center, buying all kinds of storage, servers, hypervisors, all that good stuff. Is a pretty significant CapEx, CapEx intensive activity that happens every 3 to 5 years. They want to reduce the overall total cost of ownership of the data center environment. They want things to be cheaper to manage and cheaper to run. They want to buy it cheaper, they want to run it cheaper. And that would give them faster return on investment. And because the environment must be more agile than we've had in the past, that gives faster time to value for new workloads that we're going to deploy in that environment. And we want a streamlined tech refresh. We don't want to have to rip and replace things at the end of a replacement cycle. With some systems we have in the market today, we have to actually tear them out and put them back in because it's been end of life, and the stuff that was around 3 to 5 years ago is no longer available and can't be integrated with the new stuff. We need solutions that we can grow organically and granularly and then shift to new generations of that hardware without having to do a forklift upgrade every 3 to 5 years. So we're looking for cloud-like benefits. Now, this could be public cloud, but it might be the right private cloud as well, because you can get these activities and these benefits with the right private cloud environment today. It's probably a combination of both. You're probably going to run a lot of your stuff in your local data center, but you're going to run a lot of stuff in the public cloud, which I would include things like Office 365, Salesforce, Google, all that good stuff. So I think we're going to see people really combining both of these things, but wanting a similar experience. They're going to want that streamlined approach. They're going to want the same kind of cost, or I should say financial paradigm that they have in the public cloud in their local environment. They want easy deployment. They want storage, compute, and networking to grow as it needs to and be easy to manage as well. And as a result of that, we want to see things that are based on converged or hyper-converged infrastructure because those are easy to deploy. We have building blocks of infrastructure that we can deploy without having to really think about all kinds of integration activities that have to take place. We're not buying storage from 3 different vendors and trying to integrate it with what we have. We can just grow the storage tier as we need to and move on our merry way. The business wants the ability to deploy new workloads and applications at any point. When they say, we need to do this, and IT, we have to do this, we've made a decision, it's really hard for the business to hear, well, we're going to have to wait 3 months because we're having these kinds of problems with this particular resource in the data center. Or it's built like a Christmas tree. I have seen data centers very recently where people were afraid to touch things because they were built so, I don't even know what the word is at this point, but it was difficult for them to actually change things. It was like a house of cards or a Christmas tree, like I said before. And that's something we just can't continue to do in IT. We want to be able to adjust workloads, move them around where it makes sense, and then scale the environment very easily. As we need more resources, we should just be able to add more resources without it becoming a downtime event or without it becoming sort of this exception-based thing that we have to do. Our businesses will continue to grow, so we want to make sure that we can have a feature-based scaling platform rather than something that grows by exception. And we want support for emerging technologies such as Docker and container support. And we want to work with a vendor that as these things hit the market, they can add support for these new features without us having to go out and constantly reinvent the wheel. And we really want to think about this in a multi-tenant way. Now, that doesn't mean that we're going to have lots of different companies working in our environment, but we might want to have marketing and sales have their own environment to work with, even if it's part of a larger environment, so that it appears as their own dedicated place to live. So we might go with multi-tenancy here, multi-department tenancy, rather than multi-customer tenancy, but it's a similar concept. We also want it to be highly available out of the box. It just needs to work. It has to work all the time. 100% virtual. This is life today. Everything's virtualized, and it's going to continue to be that way, and we're going to virtualize more and bigger applications. We need an environment that is virtual first, or virtual only, in fact, and supports even the largest virtual machines that we can throw at it. But we also want to support both for general purpose workloads as well as specific applications. And there's applications that have specific needs around things like storage and I/O requirements and compute and RAM. We need an environment that we can grow in such a way that we can take advantage of the capabilities of the environment, but also have that specific support for some specific applications. And we'll hear about that more on later on in this presentation. And we want massively simplified administration. We need something that's easier to manage. There's just no two ways about it. The data center is very complex. It requires highly skilled people, and it's not something that we can continue to grow one-to-one. As the data center grows, we have to basically have people that can continue to manage those resources without having to add more people to the bottom line. And with that, I'm going to turn it over to Cloudistics to continue on with the presentation.
Well, I couldn't agree more with your setup and your lead-in, and we're seeing the exact same things. And it's funny, I was sitting down with a CTO the other day, and the subject of shadow IT came up, and he said every so-and-so director or manager in this place with a credit card has his own IT department, and it's driving me crazy. Just the simplicity of the ability to stand up these applications so quickly is great. It gives you that agile development, but it is a little bit of the Wild West out there. So, and they're looking to, how do you balance agile infrastructure, quick application deployment, but still give you that level of security? So, absolutely, so we must be talking to the same folks.
Definitely.
So, as I kind of click into this, if you have some comments, I'd love to hear them as we go through this. But what I'd like to do is kind of introduce the audience to this concept that we have, which is an on-premise cloud. We call it cloud in a box, and hence the name Cloudistics. And what's interesting is, when we started, let me see here if I can slide the next. Oops. I don't have control. If you could hand me the.
Make sure.
Click.
You do have control now.
Okay.
Whoop.
There we go. So, essentially, thank you very much. Oops. Perfect. Sorry, thank you. This is live, folks. So, when we look at what Cloudistics is, it's a complete on-premises cloud, and it's everything you need in a simple kind of plug-and-play, hyper-converged appliance to build your own cloud computing platform. And, in addition to just having the platform, there were a couple of tenets that we thought were important to be able to deliver on. One is that was scalability of performance, scalability of resources, and really, really simple ease of use, such that any IT generalist could stand up and deploy applications very quickly without having to manage all the infrastructure and really abstract the experience away from managing hardware, right? So we really wanted to talk about this experience, but it also has to be inexpensive to use. And in fact, our solutions are designed to be about a third of the price of moving workloads to a typical Amazon infrastructure, or even less of when you compare to AWS. But when you look at what we've done with this kind of cloud in a box, we implemented a very modular and scalable design in that you can scale storage and compute resources completely independently. If you look at kind of traditional hyper-converged architecture, they're bound. And what we do is we break that bind and allow that compute to grow completely independently from storage, because as you mentioned earlier, the applications have different needs, data centers have different needs, and this gives us the ability to add those on demand as needed and really scale this concept of this cloud out. Whether I need more compute or more storage, it scales very simply. And probably the thing that we're really most proud of is the simplicity. And we took kind of an Amazonian approach, if you will, to the interface, and we call it our Ignite Cloud Controller. And it's a single pane of management that manages the entire infrastructure. All aspects of the data center are managed from the single pane of glass. So the IT generalist can, literally define storage very quickly, define networks. All networks are virtualized and defined completely in software. And we'll talk a little bit more about that as we go through. But the idea that they can literally launch applications in minutes from instantiation of the hardware is fantastic. And it even integrates from a hardware perspective, allowing us to proactively manage that hardware, in that if there's certain problems that may occur in the infrastructure, we'll alert the management team or the IT proactively, so you don't have to wait for failure. And this cloud console is available as a cloud SaaS-based portal, but for customers who have regulatory issues that don't want to have anything in the cloud, you can bring this cloud controller, if you will, on premise. And so, completely secures the environment. The other thing that was important is you have to design this for performance. You have to design it for the next generation or the current generation of applications. And we used an all-flash storage array. So storage is included, compute is included, but we decided to go with an all-flash array because it delivers unprecedented performance. And as we'll talk a little bit later, we have some secret sauce in the software that actually allows us to drive fantastic IOP performance to the application that you just can't see in traditional converged or hyper-converged infrastructure. And the other component is density. We give you a nice, dense configuration so that it doesn't take up a lot of space in your data center, which is kind of an important component. Now, as we look at the platform itself, just to kind of show you what it looks like, you can kind of see some of the performance numbers that we're talking about here. And so first off, you'll notice there's 3 independent blocks. There's a network block, a compute block, and a storage block. And the concept is we're the only hyper-converged solution that delivers its own network or software-defined network switch. And what's interesting about that is that gives us the ability to tie everything together with a very fast, very performant network and control all the network configurations. Again, we'll talk a little bit more about that in a moment. But let's look at the performance side of it. So we can deliver at a VM level over 30,000 IOPS to a particular VM. Now, you may not need that much, but there's certain applications coming online, with Splunk, Hadoop, big data type of applications where you really want to process things quickly. The entire backplane, everything is connected at multi-bonded, multi-path, 10 gigabit connection, so we can actually have 40 gigabit bandwidth. The switch backplane, for example, is almost 1.5 terabytes of throughput and capacity. And storage is upwards of 200,000 IOPS in just 2U. Now, one of the other advantages of this solution is when you look at this, if I need more than my 96 terabytes of storage in a storage block, I simply add another one. It's very simple. And it's also important to note there's no single point of failure in this. Everything is fully redundant to add resiliency to the platform because you need to ensure maximum uptime. And so we take all these resources and we pull them together in kind of an elastic cloud of compute, right? So it combines all the available resources of compute, storage, and network and memory into this single elastic cloud. And then you can carve up this cloud either to your applications, to your users, or to departments, as you said, multi-tenancy. Let's carve out this slice of the cloud for marketing. Let's carve off this slice of the cloud for sales. So it really gives you some flexibility.
So one of the other things here, Todd, is there's the software piece, but there's the hypervisor, right? When we're thinking about moving from what we have to what we're doing now, what is Cloudistics doing on the hypervisor side of the equation?
So what we did is we actually took a fresh approach to the hypervisor, and we are KVM based, and we made a decision to use the same kind of hypervisor that's in use in all of the web scale internet sites that you see today. So KVM is the hypervisor choice now of Apple, brain fart, eBay, et cetera. A lot of the big web scale environments are all KVM, and there's literally hundreds of thousands of these hypervisors, almost millions, let's say, already implemented and installed.
Cool.
Let me just. Seem to not be able to move to the next slide again.
Nope, you're on the next slide now.
Thank you, sir. So, but you bring up a great point, which leads me to this next thing: is how do we do it? And this is where we software define and virtualize everything, right, into a single integrated package. And what's funny is we've been promised software defined data centers for years, just like we've been promised flying cars. But we have a completely software defined data center in that 6U appliance, right? That gives you all the capability that you need. And we brought the 3 disciplines, of server, storage, and network under one management portal. And it starts, as I mentioned earlier, with the network virtualization layer. It's kind of a critical component. And we're the only hyper-converged player that actually brings in true network virtualization. And it's different than what you might see from other solutions where it's more of an orchestration of the network. We truly software define everything in the network, including the rules. And so we can deliver things like micro-segmentation so that we have built-in firewalls. So I can define different workloads and ensure that the network that these workloads are operating in is completely secure and segmented down to the application. So it really enhances the security profile. But the other component that we delivered in our network virtualization stack is we do it in layer 3 without encapsulation. Now, I know that gets into a little bit of a technical wonk, but the real advantage is it gives us unprecedented performance. So as a result, we can use this virtual network for both compute connections as well as storage connections, and it gives us really fantastic flexibility in moving workloads around to optimize the performance of the application regardless of where the application resides in the hypervisor or connected to the storage, right? So it really gives you a lot of great things. And we also build in a lot of microservice functions, distributed firewalls and things like built-in DHCP servers. So one of the chief concerns we hear from people is how long it takes for an application to be deployed. And 9 times out of 10, the holdup is really on the network, getting it provisioned, getting it defined, and getting the IP addresses before I can even launch my application. We now put this 100% in control of the user who's deploying the application. So it's very simple, very straightforward to kind of get that kicked off. And I guess the next component, and you kind of led into it, thank you very much, was, what are we doing from a hypervisor? And we decided to use KVM. And as I mentioned, it's in hundreds of thousands of sites, and it's one of the more powerful web scale hypervisors out there. And, when we look at it, from a spec mark perspective, it delivers absolutely fantastic performance. And we couldn't be happier with it. And it gives us some functionality that's kind of unique in the marketplace as well. So in addition to being able to expand the physical footprint of our cloud by adding compute and storage to a running machine, right? If I need to add disk or I need to add compute, I don't have to take anything down. I simply insert it into my infrastructure and it grows my pool of compute, or grows my cloud. Well, we've taken that and brought it down into the hypervisor in that I can now hot plug CPU and memory into running virtual machines without a reboot. So in the case of big data applications, let's say I need to hurry up and get a workload done, or there's a lot of people that are waiting. I now have the ability to balloon with CPU and memory the particular workloads that I need to enhance. So it gives me a lot of advantages there. The other thing that it really does is it sets me up for the future. So for example, we partnered with Docker to deliver integrated container support into this platform. So now, whether you have, if you've built your containers in Amazon or Azure or on bare metal, you can now take those and bring them onto our platform with no change. And again, we'll talk a little bit more about that, but it's kind of cool. And then, again, it has to be brain dead simple and easy to use. So everything is managed from that central SaaS portal, single pane of glass, automatic updates, multi-tenancy. So if I have multiple data centers or multiple geographic locations, I can manage from a single point of single cloud, single point of management, and run different types of applications. I can run them from the beach, right? Wherever I have internet access, I can manage the entire configuration. Again, down to the hardware if necessary. And then finally, we software-defined storage, another critical component. And one of the things that we do is we've actually eliminated the concept of a file system inside this platform. And that dramatically simplifies deployment because there's no concept of VM clusters and VMFS or performance issues. Every virtual machine is carved a direct pool of all flash disk that it can then access. And this direct access actually gives us a performance benefit about 3 to 5x a traditional machine, even if it's running on an all-flash array. But when you go with this kind of configuration, you still have all the things that you need, like from a traditional SAN storage solution, like snapshotting or replication. So all those services are built in and easily controlled through the SaaS interface. Does that make sense?
It does to me.
Great. Oh. I seem to have a sticky problem with slide transitions. So.
You're okay. You're okay. It's just there's a bit of a delay when you click the mouse and then when it's viewable to you in the audience.
Oh, got it. I understand now. Thank you for that. So, I guess, to kind of sum it up, we believe that, this cloud platform delivers a better, faster, stronger experience for the IT users. All right, and it starts with that plug-and-play experience, right? So how quickly can you be up and running? And the way the cloud controller works is as soon as the hardware is actually plugged in, it self-registers all the hardware, takes control of it, and you're done. And it even gives you that simple interface literally in minutes to start deploying applications. And because we virtualized everything, everything can talk to one another. So again, it's virtualized server, network, and storage all in one. So the network is kind of the key, because if without the virtualized network, you're really dependent on some of the legacy infrastructure. Now, the other beautiful component of this network virtualization layer is it being at layer 3, it actually works with all your existing network infrastructure. So this package, this appliance can sit right alongside your existing IT infrastructure. So this can sit right alongside anything else that you're using on the environment without any additional configuration. I think we've talked a lot about that managed from anywhere single pane of glass. That's kind of an important. But one of the other things that is unique to our platform and that comes as part of this single SaaS-based console is we deliver this concept of the application marketplace. And inside this application marketplace, just similar to Amazon, we have a plethora of different types of sys-prepped and ready applications that you can download, instantiate, and run. So for example, we've done a lot of work with Splunk, and we've learned a lot about how Splunk likes to tune the OS, the Linux kernel, and to optimize performance. So that CentOS image is up in our marketplace. You can simply download it and launch it into your application. Things like Windows Server 2016 is up there, Windows 2012 or desktops. So you can take the most popular applications, pull them out of our marketplace, and be running them literally in minutes from instantiation. Now, not only can you download from our marketplace, but we can take any VMDK or VHD or any bootable ISO, and we can take that and make that into a running virtual machine. And then you can create what we call a golden master library of all your templates that don't exist in the cloud but exist on premise on your infrastructure. So it's kind of really important from that perspective. And I guess kind of the other thing to talk a little bit about is this modular approach, like I said, allows me to scale independently my storage requirements or my compute requirements based on demands. I may have an idea of what my data center looks like today, but now I have the flexibility without buying a whole new infrastructure to add compute very easily, to add storage very easily, and really kind of grow my cloud as my business grows. Make sense?
It does. This is good.
Cool. So I guess, one of the other things to kind of talk about here is with the slide update is, where does this fit in? Where are the use cases for this? So we see a couple, to be quite honest. We see a lot of people talking and looking at hyperconverged infrastructure to solve a plethora of problems, to make it, simpler, easy to use, lower costs, and obviously we fit into that as well for general purpose workloads. The other thing that we see is some actual cloud-based, requirements where customers are saying we want to build a on-premise cloud, and this is a great infrastructure to do it right out of the box. So it gives you that capability of deploying a cloud-like infrastructure. Now, one of the other things that we do, you mentioned CapEx versus OpEx. So our customers have the ability to acquire the technology either CapEx or OpEx, right, based on their needs, and that gives them again flexibility not only of the cloud, but the financial flexibility of how to consume the cloud, which is another critical component. But one of the other things I'd like to touch on a little bit is we're seeing this as an application-specific infrastructure because of some of the performance metrics that we can deliver. So for example, some things like big data and Splunk and containerization, these are kind of applications that they're looking for next generation of infrastructure, but the public cloud isn't really the right place for them due to the amount of data that has to be moved up into the cloud, et cetera, network latency, et cetera. And so we kind of look at it this way, is that we're leapfrogging the current generation of hyperconverged infrastructure to kind of deliver what we're actually calling superconverged, Right? In our mind, what that means is the flexibility and the scalability of a traditional converged infrastructure with the simplicity and ease of management of a hyperconverged. And so, that's the term we've come up with.
So Todd, as you add more, I mean, going back to how you scale the environment, as you add, if you need more storage, you can buy just another storage block. That's one of the key differentiators with Cloudistics, is what I'm understanding. Is that correct?
Correct.
And that's definitely quite unique in the world of hyperconverged infrastructure.
And the thing that's, I would say that the other thing that's interesting is it doesn't have to be at a block level. It can actually be within a chassis itself. You can grow. So, for example, we can start with as small as 3 terabits of storage in a single 2U chassis, and you can add up to 96, up to 96 before you're having to leave that storage block. So you can buy in at a very small amount and you can grow. And our pricing model is such that there's no penalty to buy a little bit and grow. It's the same, similar to a cloud metric.
That's and now going back to your other point about CapEx versus OpEx, you said that you could make a choice on how to buy it. Can you expand on that a little bit?
Sure. So we have a wide range. So you can buy the unit right up front and have a CapEx, and it's a 3-year all-inclusive pricing that gives you full 24/7 support, as well as hardware support. If anything should fail, we replace it next day or same day, depending. So that's more of a traditional acquisition. We then can actually do 2 things. We have a subscription base where there's an upfront fee and you can pay on a utilization basis. So based on how you're using the technology, how many VMs you're using or how much storage you're using, we can charge you by that metric, right? So it's a consumption model. Again, there's a little bit of an upfront cost, but your monthly consumption varies, right, based on what you're using. And then there's a traditional kind of leasing type model where you can amortize and pay for the entire infrastructure without kind of a usage model, just simply monthly payments, and take that as a operating expense as well. So we're very flexible in how we can deliver this.
Very nice.
The customer is always right, and so we try and give them the options based on their models. And what's interesting is more and more times, if people can kind of get in without a lot of dollars, I mean that's why you have that shadow IT, because the barrier to entry is so low, if you will. We're trying to lower that for people to be able to bring this on and try it as well.
Right, and it makes a lot of sense, especially because I like to call it IT with a credit card, because that cost of entry is so cheap. If you can replicate that locally, that can be pretty powerful.
Yeah, absolutely. And that's the thing. Who's got the credit card? They can potentially now have an IT department.
That's right.
Just kind of a couple of quick more slides and to talk a little bit about some things. We mentioned the cost of the cloud, unexpected cost of the cloud, and probably about 6 months ago, we were approached by Docker. And they had a couple of large customers that were kind of all in the public cloud, running their containers, but the bills were massive. We're talking upwards of $5 to $7 million a year to run these types of environments in Amazon. Whereas you could uncloud that infrastructure, bring it back on premise inside of our platform for literally much less than a third, almost 20% of that cost. So it's almost like an instant savings. And in order to do that, the whole beauty of Docker is invisible infrastructure, not having to worry about the infrastructure, and the portability, right, and the simplicity of containers. And by the way, we are seeing a large number of IT departments containerize. I'm doing my little fingers with my air quotes. Containerize their legacy apps to make them, bring them into the next century, or bring them into this century, I should say. And this is a great way to kind of do that. So all the storage and network primitives that make Docker work are baked into the platform, so that the DevOps guy who's running containers or building containers has no idea that they're running on the Cloudistics platform versus an AWS. They just start it in a different location. And so we integrated with Swarm, for example, so that we have that complete orchestration layer right from the platform. And one of the really cool things is, because of the density and the way we use affinity rules for the solution, I can have a single solution that actually encompasses QA, test and dev, and production in a single appliance, and ensure that they're all completely isolated environments from one another, all on completely different virtualized networks. So that really lowers the cost.
Does that also allow you to dictate sort of how performance will happen in each environment as well?
Absolutely. You can scale up production and scale down test and dev, or vice versa. But one of the beauties that we have is a complete oversubscription model. So, what happens is you can oversubscribe everybody, but then once you start hitting the capacity of the box, set up rules about who gets what when.
Got it. You want me to move to the next slide for you?
Yes, please. Sorry, I must have clicked on the
No worries.
So I guess the kind of the last thing we talk a lot about that's been driving some interest is big data type applications, and there's a lot of big data applications out there, but two that kind of come to mind for us are Splunk and Hadoop. And when I think about big data, and I love your opinion, it's really about how much data I can ingest, how quickly I can analyze it, and how quickly can I spit out a result to somebody. And
absolutely.
And when we talk to Splunk folks, the entry level is 500 gigabits a day, right? And some of them are going to 2 and 4 terabytes of ingest a day. And I've been doing this for a while, as have you, and that's to me almost inconceivable how much data is coming into the central location that's being processed.
Yeah.
But we worked with Splunk and third-party folks to kind of tune the infrastructure for big data. And we have the ability inside this relatively small footprint to take upwards of 10 terabytes of ingest a day because of all the I/O performance that we get and the amount of storage capacity. And the result is I can lower the TCO of a Splunk deployment literally in half. And the Splunk guys like it because that leaves more room for them from a licensing perspective. The end users like it because they can get the reports that they need without spending as much. IT likes it because it's a very simple infrastructure to manage. They don't have to go stand up a new set of LUNs and define new networks. It's almost like Splunk in a box, like Cloud in a box. You can just kind of deploy it. And the same thing kind of really goes for Hadoop as well. It's all about fast index and storage. And, one of the interesting things when we talk about big data, again, I'd love your opinion on this. When we talk about big data, we see a lot of big data that's still being run on bare metal infrastructure, big Hadoop clusters that are running on physical pizza boxes out there because they get the better performance and it's just easier. But we've been able to get third-party validation that our performance is actually about 3x bare metal because of the unique way the VMs access storage and our network virtualization. And so I can now go to these companies that have gone back to bare metal for the big data applications, give them the benefits of virtualization from a manageability and simplicity, but even improve the performance. So we're getting a lot of people talking about that, a lot of proof of concepts, a lot of deployments in that area. And do you see bare metal for those types of apps as well, or?
Absolutely, I see it all the time, especially when we're talking about Hadoop. People are building out relatively complex and expensive bare metal based infrastructures just because that's the kind of I/O requirements, especially that those kinds of clusters are going to demand.
There's a customer that's not too far from us, that a Hadoop customer, that every quarter they add about 12 nodes of compute into their cluster. And when they do that, they take the cluster down, they have everyone come in for 2 days on the weekend, reassemble it, and go. And our concept was, well, why don't you just throw in a couple of compute nodes and add some storage to a running system and everyone go home early? It's like, when can you bring in a box?
Have you brought the box in yet?
We're doing it. It's going in next week.
Awesome.
Well, you have to stay tuned for the results. I think it'll be spectacular.
Whoop, there we go.
Whoop, there we go. So, I guess, that's kind of the presentation. I hope I didn't drone on too long for everybody. One of the things that's interesting, we have several ROI calculators that allow you to put in your different types of workloads and churn out what it would cost to run on our platform versus an AWS. So I encourage people to look at that. We'd love to show you a demo to show you how simple it is to use. We also have videos up on our website if people want to take a look. Because it is a cloud, we have virtual lab demos where we can set you up in your own private cloud infrastructure and access through the cloud and test just think of it as a virtual proof of concept. And we do ship boxes for those people who are interested in it and have a serious need and are looking to solve some problems. So we'd love to work with you or anybody that's on the audience or in the audience, I should say.
These are definitely three options people have in front of them to continue to engage with Cloudistics and learn about it. We have some questions from the audience. Are you prepared?
I am as prepared as I can get, so I will answer what I can. I will defer what I can't, but I'm sure every question will get an answer.
All right, so I want to remind the audience, if you have questions, we have plenty of time. Please make sure you put them in the questions panel in the GoToWebinar control panel. And our first question is basically, what's the starting point for Cloudistics? Basically, I guess what do I need to buy to sort of get my foot in the door?
So, gotcha. So the starting unit is what we call our entry-level unit is 40 cores, 256 gigs of memory, and 6 terabytes of all-flash storage. Now we work through channel partners, so these are MSRP prices. You may have a relationship with your partner that can get you a better price, but the MSRP is just under $75,000 for that particular unit. That is full 3 years. Includes all service, all warranties, any repair.
So that that MSRP you said includes maintenance for 3 years as well?
It does indeed.
That's impressive. That's actually unusual.
And one of the other interesting things, just to kind of put it into perspective, when you think about hyper-converged infrastructure, we do things a little bit differently in that we have redundant storage controllers and we use traditional RAID 10 and RAID 5 sets. And so we don't have to have multiple nodes to replicate. So when that price is all you need, that gives you 2 physical nodes, and you don't need to have a third node or a quorum or anything like that. That's out the door, ready to go.
One of the things I'd like to point out to the audience is that in the GoToWebinar control panel, there's a handout section, and you're going to see that we have 3 handouts to provide you with. From Cloudistics. One is a data sheet, the other one is a modern applications overview, and the other one is information about their super converged infrastructure platform. So I'd highly recommend you download those files and take a look at them because they can help you learn more about what Cloudistics is bringing to the table. The next question we have is, how do you distribute the firewalls? I think that the person's reacting to the microservices-based approach in the networking side of things. I'm not 100% sure what they're asking, but does that make sense to you?
So let me answer it to the best of my ability, and if it's not right, please add a question that says, no, you didn't get it, and I'll make sure that you do. So when we talk about distributed firewalls, when we establish a virtual net, a VNet, if you will, you can define a set of firewall rules that are specific to that VNet. And then once you have that software-defined VNet, you then start, or you place virtual machines inside that. So from a hypervisor perspective, what we actually do is that firewall that's been defined in the VNet is actually distributed across all the hypervisors on the platform. So we define it in the virtual network and then distribute that firewall across all the hypervisors. So as an example, it's conceivable I could have 2 virtual machines on the same hypervisor that has different firewall rules associated with it. And this is what gives us our microsegmentation. In fact, if that's something you want to learn a little bit more about, we have a fantastic white paper on our website that goes into detail about the network virtualization and how we do the distributed firewalls and microservices contained within. If that did not answer your question, please say no, it didn't answer the question, and I'll get a brighter person than I to get that answered for you.
I didn't think that was possible. Just kidding. So when somebody wants to do a test drive, how much time do they have with in the virtual lab? That's one of the questions we got from the audience.
So usually the virtual lab is a week, but we've actually had people in for as long as 30 days based on the needs and the tests that they want. So we try and go for a week, but if they have a very specific set of results or trying to get a particular result out of the firewall, it can be upwards of 30 days.
And the person said that you did answer their question, so congratulations.
Great, thank you. Stop clocks right twice a day.
That's right. So can you talk a little bit about what an application deployment might look like in the world of Cloudistics?
Sure. So, I could look at a couple. There's a general purpose workloads. So you instantiate the machine, you fire it up, and I'll give you an example we're working on with the guy right now, where they've got they want to they have a very highly transactional SQL database, for example, and they're just not getting the performance out from it's an e-discovery application that's running. And what they really want to be able to do is improve the performance of that application. Now, that SQL Server, for example, also gets a lot of data feeds from several other data sources that are not on our platform. So what we've done in this situation is we've actually deployed a SharePoint and SQL farm on our platform that's running on all flash storage. In fact, it's actually running on Windows 2016, for example, in this particular account. Nice, fresh, new operating system. But we're actually tied into their existing network for Active Directory validation and some of the DHCP stuff that's happening. And so we're taking that data from the rest of the network and bringing it into our platform for processing. That gives you one example. We have another example where, just to put it into perspective, the density. So in that 6U chassis, I can go up to 288 physical cores, 4 terabytes of memory, and 96 terabytes of storage. So we've got a couple of customers where we've taken about half their data center and their general purpose workloads and migrated them into that infrastructure. Another one, we actually have a very large Splunk deployment that is going on right now, where we're in the process of ingesting 5 to 6 terabytes a day of Splunk data. One of the interesting things about that from a storage perspective is that we actually archive the storage that's over 30 days off to Amazon. So there's a little virtual machine, worker virtual machine that we run that takes the Splunk data that's over X number of days, in this case 30, and migrates that to AWS. So you can see kind of the first hybrid nature of the cloud, from the on-prem cloud leveraging storage resources from the public cloud.
I have a question about storage as well. And the person says, is this geared more towards SAN, NAS, or both disciplines of storage?
Well, the storage is unique to our platform. So technically it functions a little bit more like a SAN, although we abstract all the complexity. So there's no LUN management, for example, associated with it. So maybe if I describe the way it works a little bit more, it'll help you kind of bucket it. So imagine, you take all flash storage, and then what we do is we actually carve it up and associate the kind of a raw block device to each individual VM. So each virtual machine that's running has direct access to those blocks of storage. So the concept of a cluster is eliminated. The concept of an intervening file system is eliminated. So, it isolates performance as well. And so we are essentially doing that through a private iSCSI connection between our compute node and our storage node.
Excellent. And that's all the questions we have. Are we ready to give away some Amazon gift cards?
Always ready.
All right, there's going to be 3 of them. They're $100 each. The first winner is Amy Gloin. The second winner is Roberto Backlin. And the third one is Emil Mokuabeka. Sorry, butchered it. But we have your name, and we will email you details on how to claim your gift card. Thank you, everyone, for being here. Thank you, Todd. This was really great.
Thank you for your time. Very much appreciate it. And thank you to the audience. I really appreciate you sticking with me, and hopefully it was educational and learned something. Thank you.
Thanks, everybody.